Hey guys, welcome back to Worms Maths Academy. Just starting Northern Hemisphere Exam 2, 2019. I think most of you want this because I keep getting people messaging me and sending me emails. So yeah, so this is the second section. I've done the first section in another video. I will hopefully get through this in the time that we should. Can't remember how much the first half took, but yeah, let's have a look at this one. I don't think Northern Hemisphere exams are written as well as VCAA, mainly because there's not as many kids doing it, so they sort of don't really care as much about it. Okay, parts of the graph of f of x is x minus 1 cubed, x plus 2 cubed, g of x is x minus 1 cubed, x plus 2 cubed, as shown. Okay, so we've got f of x and g of x. F of x is 2 cubics. Basically, that's why we've got a point of inflection here, point of inflection here. And the other one, we've got a turning point and a point of inflection. Okay, that makes sense. The two graphs intersect at 3 points, negative 2, 0, 1, 0, and CD, which is going to be somewhere over here, I'm assuming. Okay, I always tell my students, call them the same thing that they are in your CAS. This is going to be annoying. X minus 1 cubed, x plus 2 cubed, maybe. Yep. And then I'm just going to go out here and do it. So paste it and define that as f of x, and then pretty much the same thing, but there was a turning point there, and that is g of x. Okay, we want to know when they're equal. So this exam's all about efficiency, being able to do things pretty quick. Negative 2, negative 1, 1. Okay, I've stuffed it up. X minus 1 cubed, x plus 2. 1 cubed, x plus 2. X minus 1 squared, x plus 2 cubed. Because I knew that I couldn't actually have those solutions. Okay, so our extra solution is 2. So we know if they intersect at 2, f of 2 and g of 2 will equal the same thing, which is 64. Okay, so c is the x value, 2d is the y value, 64. Find the value such that f of x is greater than g of x. So just CAS it. I can just actually grab the whole thing. F of x is greater than g of x. X is less than negative 2, or x is greater than 2. Oh, this is really annoying. X is less than negative 2, or x is greater than 2. Oh. Find when f dash of x has a positive gradient. So d dx f of x is greater than 0. Solve. X is greater than negative 1/2, but it can't equal 1. So negative 1/2 to 1, 1 to infinity. I think that's right. Yep. What was the other one? G dash of x. So let's change that to a G. X is less than negative a fifth, but it can't equal negative 2. Okay, so negative infinity to negative 2, negative 2 to negative a fifth, and x is greater than 1. 1 to infinity. There's no equal to's. Okay, show that f of m plus 1, 1 plus m. F of 1 plus m, 1 plus m minus 1 cubed, 1 plus m plus 2, cubed is, they cancel, so we get m cubed, 3 plus m cubed. You can't do a hell of a lot with that. It's negative 2 minus m, negative 2 minus m minus 1 cubed, negative 2 minus m plus 2 cubed. That and that cancel. So we've got negative m cubed. Then we've got negative 3 minus m. We could take the negative out. 3 plus m. It's all cubed, which is m cubed. 3 plus m cubed. Therefore, as m cubed 3 plus m cubed is equal to m cubed 3 plus m cubed, f of 1 plus m is equal to f of negative 2 minus m. Find the values of h such that g of h plus x, h plus x, so it's going to move it left and right. So g of x plus h, sorry, x plus h, g of x plus h. So let's sketch g of x. Okay, so plus, let's put a h in, and now what did it ask for? Exactly one negative solution. Come back. Okay, so there I've got one negative solution. So when h is 1, I've got 0 and negative 3. When h is 0, I've got one negative solution. When h is negative 1. When h is negative 2, I don't, but any other value in between I will. So my lower value is negative 2, but not included. And my upper value is 1. So h is an element. Negative 2 not included. 1 included. So if it's 1, I've got one x-intercept that's negative. And if it's negative 2, I don't have any. Find the value of k such that f of x plus k has no solutions. Okay, so, so if we sketch, get rid of this, put in f of x. Okay, k is going to move it up. So if we say plus k, yes, I get it. So it's going to move it up, up, up. We need to find what that turning point is. So get rid of this. It's a minimum. So go out to your main screen and then put f of x, and it's the minimum on the whole for the whole graph. So calculation f min That's it. So my lowest value is negative 729 on 64. So if I move it up 729 on 64, K has to be greater than 729 on 64. So let's just test it. If we did K plus 729 divided by 64, it should be right on the turning point. And then if I add plus 1, yep. So we know it can't be equal to, it's got to be greater than. Oh, next question. Well, that was boring. Okay, scrap whatever we've got. Clear the cas. We'll just write functions over the top. Okay, 20 plus 16 sine pi x on 14. 20 plus 16 sine pi x on 14. I know you're probably getting sick of my voice, but I have to say stuff like that out loud so that I remember what the hell I'm doing. Okay, so we call that f of x, where v is the speed of the wind, in kilometers per hour, and t is the time in minutes after 9 a.m. What's the amplitude? The amplitude is 16. The period is 2 pi on 14. Which is 2 times 14, which is 28. Time in minutes. Okay. So, what's a maximum and minimum wind speeds at the weather station? So, if we know our center's 20, if we add 16, max is 36 kilometers an hour. Min 20 minus 16 is 4 kilometers an hour. I'm pretty sure that's all they want. It's really weird that they've got kilometers an hour and then it's a time in minutes. But I guess it's just a wind speed, so they're not actually connected. Okay, find V of 60 correct to 4 decimal places. That's nice on your cas. Make sure it's in radians. And 32.5093. 32.5093. What is the average value of V of t for the first 60 minutes? So 1 on 60, 0 to 60, V of t, dt, which is f of x. So 1 on 60 at the front, 0 to 60, f of x dx. Did it say exact? Okay, 2 decimal places. 20.044. Does that seem logical in terms of the speed going between 4 and what was it, 36? So I guess that's kind of in between. So 20.45. Sudden wind change occurs at 10 a.m. From time to time, the wind speed varies according to the new function. 28 plus 18 sine. 28 plus 18 sine pi t minus k. Awesome. Pi x minus, let's keep it as k so we don't get confused, on 7. Different period as well. Let's call that g of x. Okay. The wind speed after 9 a.m. The wind speed kilometers an hour. Find the smallest value of co-corresponding spaces such that v of t and v1 of t are equal in both increasing at 10 a.m. Okay. So we'll find value of k. Okay, so we let them be equal for v of 60. So if I said f of 60 equals g of 60 and solve for k, let's just say, I don't know, let's make k go between 0 and 10. Oh, you couldn't, what's the period? The period is 2 pi and pi on 7, which is 14. So we go between 0 and 14, because that way we know that the graph can translate up to 14 left and right. And that's a k. Okay, 3.43, 11.56. So it's got to be 3.43, of course. So v of 60 equals v1 of 60. Therefore, k is equal to 3.4358. Is it 4 decimal places? 3.4358. It's a bit of a weird question. Another possibility of k was found to be that, since the signal the wind speed is greater than 30, okay, 31.4358. 31. Okay, so now we can put that in there. 31.4358, was that right? Okay, so I've defined that. So now let's sketch them both. F of x and g of x. Okay, let's go from 0 to like 100, because we know what 60 is when they're supposed to join. So we say here, given 0 is less than or equal to x, which is less than or equal to 60. And then here we say the same thing, but we go from 60 to 100. Okay, so they've got the same value there. And that's with that value. Okay, find the value of t, which I figure when the wind speed is greater than 38 kilometers an hour. So we can then put 38. Okay, so we can let that function equal 38, and we want to know when it's first 38. So what am I doing? So g of x equals 38. Solve, and we only want it, so 60 is less than x, which is less than maybe 80. So 60.7482. T is 60.75. The proportion of the cycle for one cycle to the nearest whole percent. Okay, so we say t is equal to 60.75. We can say T2 is 65.123. T2 minus T1 is that minus that, 4.375. And then, therefore, 4.375 out of the period. What did we say the period was? 14. Divided by 14 times 100. So 31.25%. Therefore, 31% to nearest whole number. Okay, that to get to that. Alright. That maps a graph of that onto that. State the values of A, B, and C where appropriate. Okay, so I'm thinking if we've got to get the dilation factor occurs first. So if we want to go from 16 to 18, we've got to multiply it by 18 on 16, which is 9 on 18 on 16, which is 9 on 8. Now if we do that, let's go back. So we'll sketch it so we can actually see. F of x, g of x. Get rid of that. Okay, so if I say 9 on 8 and then sketch it, they should have the same period. Okay, we've got to make the period the same. So at the moment the period is pi, well, we know that the n is pi on 14. We want to make it pi on 7. So we're going to have to times the bottom by 2. So we'd have f of x on 2, which is a dilation factor 2 from the y-axis. That's b. So b is 9 on 8 because it's from the x-axis. A is 2. So if we said f of x on 2, sketch it. What do we want? 2x. Okay, so f of 2x, f onto g. Oh yeah, because we want to make that a 7. It's a 14, so we've got to put a 2 on top, which is a dilation factor a half from the y-axis, so a has to equal a half. Okay, next we have, we've times that by 9 on 8, so 20 times 9, because we dilate first, 20 times 9 is 180. So 20 times 9 divided by 8. So it's 22.5. So we've got to move it down 4.5. So D is negative 9 on 2. So let's try minus 9 on 2. Is it plus 912? What? At the moment, when I've multiplied the whole function by 9 on 8, if you multiply that by 9 on 8, oh, yeah. So what did I say? If I multiply it by 9 on 8, I get 22.5, but I've got to come up to 28. So what's that? Plus 5.5. So plus 11 on 2. So let's try that now. Let's my stuff up. 11 on 2. And then let's try our dilation factor. Let's move it 2 to the right. 3. I don't think it's quite exact. What will it depend on? Oh, if I'm going from x to x minus k, then we know c must equal k, because I'm moving it k units to the right. So that was for a specific value of k, but k could be anything. So d equals 11 on 2. Yeah. So if we apply all those transformations to this, we would get this. I didn't realize it said in terms of k. I'd forgotten that it was, I thought we were only using this value, but we're not. Okay. Good, that question's over with. Okay, Massland Concert Hall begin at L minutes after the scheduled starting time. L is a random variable is normally distributed with a mean of 10 and standard deviation 4. What problem begin before corrector? Concerts at Massland begin L minutes. Okay. So we want to find the probability that L is less than 0, because that's when they start on time. So we can clear all this. Interactive distribution, continuous norm CDF, negative infinity, up until 0. I know my mean was 10. Was the standard deviation 4? 4. Why do they write one as 10 and the other one as a number? 0.0062. Final probability concert begins more than 15 minutes after the scheduled starting time, correct to 4 decimal places. So the probability that L is greater than 15. Actually, they're probably going to make us use that later in the question, although they might not, I don't know. So 15 to infinity, 0.1056. Okay, if the concert begins more than 15 minutes late after scheduled time, the cleaner is given an extra payment of $200. If the concert begins up to 15 minutes after the scheduled starting time, the cleaner is given an extra $100. If the concert begins at or before the schedule, there is no extra payment for the cleaner. Let's see whether okay, using your response for part A, complete the following table corrector. 3 decimal places. Wow. 0.006, 0.106, plus 1 minus that, 888. So our expected value, E of C, is 100 times 0.888. So I'd actually still use the real value. So I'd delete that, get rid of that, plus that. So then I've got my answer here. So I've got 0, I don't need to do 0 times, 1 times that, but it was 100, plus 200 times that one, 109.94, $110. Calculate the standard deviation of C, correct to the nearest dollar. Okay, so standard deviation, we've got E of x, that's E of x. E of x squared is going to be that, and plus that. So 200 squared, 100 squared. So E of x squared minus E of x all squared, and then square rooted, 31.93. Standard deviation of C is $32. Okay, the owners at Mathline School decide to review their operation. They study from 1,000 concerts at other similar venues, collected as a simple random variable. The sample value for the number of concerts that start more than 15 minutes after the scheduled meeting is 43. Time. The sample value for the number of concerts that start after 15 minutes is 43, so 43 out of 1,000. Find the 90% confidence interval, the proportions that begin more than 15 minutes late. Give your answers correct to 3 decimal places. So 43 out of 1,000, 95%. So, statistics calc interval, 1 prop Z, confidence level is 0.95, X is 43, N is 1,000. So 0.030 and 0.056. 0.030, 0.056. Explain why the confidence interval suggests that the proportion of concerts that begin more than 15 minutes after the scheduled meeting is different from the proportion. Explain why the confidence suggests that the proportion of concerts that begin more than 15 minutes after the scheduled starting time at Massline Concert Hall is different from the proportion at the venues in the sample. The proportion, that's 1056. Because the proportion of concerts at Massland Hall or whatever it's called Massland Hall. Proportion of concerts greater than 15 minutes late at Massland Hall are outside this confidence interval. So in the sample, i.e. 106 is not in 0.3030. This is a bit of a stupid question. So because it's not in that. The confidence interval suggests that the proportion of concerts that begin more than 15 minutes after the scheduled meeting time at Massland Concert Hall is different from the proportion at the venues in the sample, because that is not contained in there. Don't know what they want you to write. Okay. The owners of Massland Concert Hall decide that concerts must not begin before the scheduled starting time. They also make changes to reduce the number of concerts that begin after the scheduled starting time. Number of concerts that begin. Okay, following changes, M is a random variable that represents the number of minutes, blah, blah, blah. Okay, well, calculate the expected value of M. So we want to go from 0 to infinity, x times 8 on x plus 2 cubed dx. So 0 to infinity 8x on x plus 2 cubed dx 2. So E of M is equal to that, which is equal to 2 minutes. You can read that. Okay, so we expect it to be 2 minutes. Find the probability a concert begins more than 15 minutes after the starting time. This is such a waste of time. So we go from 15 to infinity, get rid of the x. Probability that M is greater than 15. Okay, this is bad. Oh, I'm like, why is it giving me a decimal? 4 on 289. Because your calculator is in decimals. Find the probability that each of the next 9 concerts begins no more than 15 minutes after the scheduled starting time, and the 10th concert begins more than 15 minutes after the scheduled starting time. Give your answer correct to 4 decimal places. Okay, 9 concerts begin before, so that's going to be 285 on 289, i.e. 1 minus that, to the power of 9, times 4 on 289, which is 285 on 289 to the power of 9 times, Jesus, 0.0122, 0.122 to 4 decimal places. Was it 4 decimal places? Yep. Okay, find the probability that a concert begins up to 20 minutes after the scheduled starting time, given that it begins more than 50. Begins up to 20 minutes after the scheduled starting time. That a concert begins up to 20 minutes, given that it begins more than 15 minutes. Okay. I thought it said given that it begins 15 minutes after. Okay. So we want the probability that m is less than 20 given m is greater than 15, which is the probability that 15 is less than m, which is less than 20, over the probability that m is greater than 15. Okay, so I want to do this. 15 to 20 divided by this. .0429.402, which is to 3 decimal places 0.402. What was it? Bloody hell. 0.4029.403 to 3 decimal places. Okay. Four questions. A mining company has found deposits of gold between 2 points A and B that are located on a straight fence that separates Mr. Potts and Mr. Negg's property. Distance between A and B is 4 units. The mining company actually models the proposed property of that. Mr. Potts' property. Okay, so let's put it x minus 2, x minus 4. So let's put that in as x minus 2, x minus 4. I'll put a times in there because sometimes it stuffs up. Define it as f of x. So f of x, zoom, initialize. Okay, determine the value according to this model. Okay, so we integrate. It is symmetric. So we could go 2 times 0 to 2 x minus 2. Actually, because it's an area and you've got a cas, you could go 0 to 4 mod x minus 2 x minus 4 dx, because you've got a calculator. Because if you mod this function, I know they don't teach this in methods anymore. See, it just bounces up. So if we integrate 0 to 4 and then the modulus of f of x dx, 8 square units. Offers to pay per square unit of his land. Mrs. What? Initially models the boundary of its proposed mining area. Okay, so we're going to have 4 square meters from each. So Mr. Ned is 400,000. Mrs. Potts is 480,000. Therefore, the total is 880,000. I don't even understand what, something must be going to happen with this question. The mining company. Oh, this is one of these questions that goes on for quite a while. The mining company reviews its model to use fence line and the graph 0 to 4, p of x minus 4, form 1 plus a. P of x equals f of x. Okay, so p of x So let's call it g of x. X minus, now they've got to be similar. 4 plus 4 and 1 plus a. 4 plus 4 and a. So we say, when does f of x equal g of x, solve for a. A equals 1. Solve p dash of x for x in terms of a. So p dash of x d dx of g of x equals 0. For x in terms of a. What? Which one's which? P of x is g of x. So when does the derivative of that for x in terms of a, is a defined? What? That's such a stupid question. Okay, so what's p? Write down what? Can we write down what p dash of x is? So d dx of g of x set it equal to 0. Okay. So x has to be positive, but it could be either of these. Okay. So 8a plus 4 plus or minus 2, because I'm timesing that 2n. Oh, 8a plus 4 plus 4. A squared plus a plus 1. Is that right? A squared plus a plus 1 on 3 a plus 3. So x is equal to either of those values. I guess maybe that's why it's 2 marks. It's just 2 a squared plus a plus 1. Mr. Neg does not want his property in mind further than 4 units measured perpendicular from the fence line. Find this condition to be met. Does not want his property to be mined further than 4 units measured perpendicularly from the fence line. So this length, it just means that length, at most can be -4. So if g of be positive. We'll say g of that, if that equals negative 4, oh you stupid thing. That'll give us the value of that a can be. Solve. For a negative, which function is he? Mr. Nedge. So it's still that function. So that's P. Did I even write? Okay, so you actually want G. Let's try plus because it can't be negative. Okay, 0.716. So we say P of that equals negative 4. Therefore, A equals 0.716. So let's have a look. If we go in and sketch f of x, g of x, and we said given A equals 0.716, analysis G solve min of the red graph, negative 4. But it's their fault because they want us to round to however many decimals. Find the value of A for which the total area of land mined is a minimum. Okay, let's have a think about this. So that's our 0 intercept, that's our middle, and this is our end. 0, middle, end. So if we were to solve this, the first area would be from 0 to, if we solve that, 4 minus 4 on 1 plus A. And then the second area we want it to be a minimum. Can we just use a modulus between 0 and 4? 0 to 4 mod P of x dx, that's our area. So let's see if the calculator can handle it. So 0 to 4 of g of x dx. Oops, I don't want that, I want the modulus of that. I'm like, that's way too easy. Okay, so it can't handle it. Let's go back to our other way. So if I say from 0 to, was it 4 minus 4 on 1 plus a, or a plus 1? A plus 1. And then what was our function? G of x dx. So I'm just thinking. So that's going to give us our first, and if we go from there to there, it's going to be negative. So if we say negative, and basically the same thing, but here we want to go from that up until 4. So that's our area. Okay. So that doesn't work. So our area in terms of A is from 0 to 4 minus 4 on A plus 1. P of x, was it? Dx minus 4 minus 4 on A plus 1 to 4 P of x dx. Then we can say A of A is equal to 64 A4 2a cubed plus 2a plus 1 on 3a plus 1 to the 4. Okay, so A dash of A equals 0 for max slash min. So if we derive that with respect to A, set it equal to 0 and solve for A. So we get 1 the other values are negative, I think. Negative, negative. So A has to equal 1. A equals A is greater than 0. So A equals, what were the other values? 1, negative 3.73. And then negative 0.268. However, A is greater than 0, so therefore A equals 1. A mining company offers to pay $1,200 per square unit of her land mined. Mr. Neg, here's determine the value of A that will minimize the total cost of land purchase for the mining company. Give your answer correct to 3 decimal places. Determine the value of A that will minimize the land cost. So they pay Mrs. Potts twice as much, and she's the first area. Is she? Mrs. Potts. She's the first area. It's so confusing. So she's on this side, so that's her land. Okay. So Mr. Potts's property, so if you think about it in terms of this first area is Mrs. Potts, and the second area is Mr. Potts. So we could say the cost in terms of A is 1.2 times 0 to 4 minus 4 on A plus 1, P of x dx, minus 4 minus 4 on A plus 1 to 4 P of x dx. That's our total cost. So it's basically back to this, but we do a 1.2 here. So let's grab this whole one, copy, paste. So if we do that, we end up with simplify, and then we want to do the same. So DDA of that, set that equal to 0. What? No solution. That's because we're not solving for x, we're solving for A. Bloody hell. Okay, 0.0886. So we say A equals negative 0.3626. Negative 0.260. And the last one was 0.866, or was it 886? 886, of course, it's the other one. Therefore, A is greater than 0, so A equals 886. Okay, didn't ask us to find what the actual property. Okay. That was pretty crap. There's 5. What? Okay, let's define these. E to the x on 2, 2 log e x. E to the x on 2. And 2 natural log of x. Define as g of x. Let's go in and sketch them, make sure they look the same. They do. Okay, find g inverse. Let y equal g of x, swap x, and actually you don't have to do that because it's worth 1 mark. So if we had 2 log e y equals x, y equals e to the x on 2, which is the same as f of x. So g inverse of x is e to the x on 2. I wonder if that's what they're trying to tell us, that they are the inverses of each other. I think it could be. Okay, find the coordinate to the point A where the tangent to the graph of f at A is parallel to the graph of tangent of graph is parallel to the, so it's got a gradient of 1. So f dash of x equals 1. Therefore a is, so if we say d dx of f of x equals 1, x is 2 log e2, and f, given x is that, is 2. Show the equation of the line that is perpendicular goes through the point A is that. Show the equation of the line that's perpendicular. So we actually have to find the equation of the perpendicular line. So what have we got? X equals 2 log e2, y is 2, m is negative 1, y minus 2 is equal to negative 1, x minus 2 log e2, therefore y equals negative x plus 2 log e2 plus 2. Why do they leave such bloody small room? Okay, so a is 2 log e2, 2. Okay. Determine the coordinates of the point B. So that equation, perpendicular. So, and we want to find the whatever's 2 log e2. So interactive calculation, line, normal line at 2 log e2. So we get that graph, and we want to know when that, let's call that h of x, define it. That's annoying. H of x. Okay, we want to know when h of x and g of x collide. So h of x equals g of x. Solve. X equals 2. So that's the point 2. Because it's the inverse, those values are going to swap, so it's going to be 2 log e2. So that's going to be 2 log e2. Okay, the shaded region below is enclosed by the axis of the graphs f and g and the line that. Find the area of the shaded region. Can we do that? It's going to be a bit annoying. We just found out what A was. We know that's going to be under f of x, and we know that this is 1. So if we go from 0 to 1 of f of x dx plus from 1 to, we know that value there for a is 2 log e2. 2 log e2, and I know it's not 0, I know it's 1. Now this time it's f of x minus g of x, because we're doing that line minus that line. And then that's 2 log e2, so plus 2 log e2 up until 2 of minus x plus 2 log e2 plus 2 minus g of x dx. Okay, and it must be a nice answer because it's find the area of the shaded region. Alright, so let's go 0 to 1 of f of x dx plus 1 to 2 log e2 of f of x minus g of x dx plus 2 log 2 to 2 of h of x minus g of x. Now let's hope I haven't stuffed this up. Dx. Okay, so negative 2 log e of 2 squared minus 4 log e2 plus 6. Actually, I should check and make sure that's positive. It's going to say that'd be embarrassing if it wasn't. I would have stuffed something up. I guess we could say square units. Okay, e to the k of x. How much longer did... Oh, I wrote at the end. E to the k of x, 1 on k, log e x, so they're the inverse of each other. So they'll touch on the line y equals x, where the gradient's equal to 1. Find the value of k. So p dash of x is ke to the kx. Q dash of x is 1 on k times 1 on x, so 1 on kx. If gradient equals 1 when they intersect. So if we let that equal 1, ke to the kx equals 1, we get x is 1 on k log e 1 on k. And then here we get 1 on kx is equal to 1, so x equals 1 on k. So if we let them be equal, one on k natural log times natural log of k equals, what was the other one? 1 on k. Solve for k. E. I stuff something up? So find the value of k. So they're going to have the same x value when their gradients are the same. Oh, so we get 1 on k log e, 1 on k is equal to 1 on k. So then from here, that, when I divide it across, I get 1. So did I stuff something up in this? I mean, it seems it could equal e. I forgot the 1 on k here. So it's 1 on k. It's 1 on e. I thought it'd be strange. I guess it could be. So here, if they cancel, e to the 1, I get 1 on k is e to the 1. So therefore, if we switch them, we get k equals 1 on e. So we know they've both got the same gradient, and that gradient's 1 because the line y equals x has a gradient of 1. I set both of their gradients equal to 1. Then, got x in terms of k, x in terms of k, let them be equal and solve for k, and I get 1 on e. Find the value of k, let's go, for which the tangent to the graph of p at its y-intercept and the tangent to the graph of q at its x-intercept are parallel. The tangent to the graph. So p at its y-intercept. So p dash of 0 is ke to the k times 0, which is k. So that's the gradient of p at its y-intercept. And then the gradient of q at its x-intercept. So when does q have an x-intercept? 1 on k log e. X is 0, that's 0. X is 1. So q dash of 1 is 1 on k. So therefore, k equals 1 on k. Therefore, k squared is equal to 1. K equals plus or minus 1. However, k is greater than 0. Therefore, k equals 1. Not a massive fan of that exam. Didn't think a hell of a lot. I don't know. I just think they've seemed to have gone off the ball a bit. I don't know that it was hard. Just stupid. Anyway, hopefully you guys found some of this useful. You probably noticed I did the whole thing on the CAS. Pretty much nothing was done by hand. I mean, I did some of the stuff by hand, but that's just because I wanted to. But I mean, you could have done it on the CAS. I just couldn't be bothered putting K's and crap into my calculator. But you will get the same thing. So hopefully it's helpful and it sorts out a few of you when you didn't know what to do or whatever. But pretty uninspiring exam. Alright, best of luck. Don't forget to like, share, subscribe, turn on notifications, blah, blah, blah. Tell your friends. If you've got friends in year 11 and they're out near Berwick, Canary Warren area, I start tuition for next year, early November, so have a look at wma.com.au and all the best for your exams. Bye.